Good day, folks. Welcome to Brett's Mind Academy, where we bring brilliance to every lesson. Now, let's look at electrolytic cell, okay? Yes, electrolytic cell. So, question 9. It says, let me try to zoom this out for us. All right. It says, the simplified diagram below represents the electrolysis of a concentrated sodium chloride solution. Guys, this word is very, very important. The word concentrated tells you that there is what? There is water molecules present there. Okay? There is water. Okay? Many people struggle with this question, especially when they say electrolysis of concentrated sodium chloride solution, and then they give you maybe, let's say, zinc, and then they give you whatever. People forget that concentrated what tells you that there is what? There is water thereof. All right, in question 9. All right, remember this is an electrolytic cell. We know that the negative, it is our cathode. Remember, in when we are dealing with galvanic, the negative is the anode, but in this case it is the opposite. So in this one, red cat occurs. What do I mean by red cat? Reduction occurs in the cathode, okay? And then an ox. An ox, what do I mean by an ox? Anode, okay? Anode, it is where oxidation occurs, all right? And then, because it's positive, okay? Then the sodium chloride, blah, blah, like that. And then the carbon rods. And then they tell you that the balanced equation for the reaction taking place in the above cell is as follows. So 2 sodium chloride plus water, sodium hydroxide, la 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 la. Now I want us to see something. It's very important, guys, that you still remember the concept of oxidation number from grade 11. If not, please watch the video under redox reaction in grade 11. Okay, there is one of the playlists there. So the sodium chloride, we know that sodium it is plus, Cl it is minus, and then H2O, we know that H it is plus, and then oxygen it is 2 minus, and then sodium hydroxide, we know sodium it is plus, hydroxide it is minus, H2 it is a pure element, so it has an oxidation number of 0, Cl2 it is a pure element, so it has an oxidation number of 0. Okay, why am I writing these? So that I see which element or compound underwent oxidation or rather reduction, right? Yes. Now let me look at sodium. Sodium here is 1, it is 1, good. Cl here it is minus, here it is 0. So can you see the oxidation number increased from -1 to 0? So an increase in oxidation number, we refer to that as what? We refer to that as oxidation. When we explain oxidation in terms of when we define oxidation in terms of what is this oxidation number, we say oxidation, it is an increase in oxidation number. So here it is. And then let me see H2. H it is plus here, but here, okay, H it is plus here, but here it is 0. So there is a decrease from plus to 0. So it means H underwent now what? What's this? Underwent now reduction. So reduction. Why am I saying that? Oxidation number decreased from plus to 2 minus. Here you can also break it and say OH it is formed by Na plus 2 minus of OA and then plus, so that you see that the 2 minus did not, the oxygen did not change, the hydrogen did not change, and then yeah, okay, yes. But I mean, you don't necessarily need to do this. If you don't want to, you can go to your table of reduction, and then let me create space here. I think I still have that table. I don't have it. Let me quickly fetch the table so that we work nicely. Okay, and then now, where's the table? I'm gonna need table 4b. Okay, here it is. Let me quickly screenshot that. Copy. Got Okay, so I see that I have what here? I have sodium. Okay, basically this is gonna be Cl minus. Remember I said Cl minus. Actually, let me ah the Cl minus. Remember I said it's gonna undergo oxidation. Okay, the Cl minus is gonna undergo oxidation. Oxidation is loss again, and then I said my what? I said my. I think I said something like H2O. Okay, so this H2O here went to H2 and it was affected. Basically, I said this H in here, which was plus, became zero here. So H2O to H, I don't want to show you the full step because it's going to be a long process. But if you are interested in how we find that without using the table, you can find that under the thingy there off. Where is it? H2O, not peroxide. Let me quickly find it. H2O that forms H2. You should be very careful. We need the H2O that forms H2. Okay? H2O that forms H2. I don't think we need H2O that forms H2 basically. I think we need, what is this? The H plus that forms H2 per se, if I can put it like that. Yeah. The H plus that produces the H2. Okay? I hope I'm making sense. No. Where can I not see this? Oh, okay, here it is, basically. The H2O that forms H2. Okay, because now why am I saying the H2O that forms H2? It is because now the plus that plus came from H2O and it went to H2. Okay, so it came from H2O and went to H2. So that this one is the one that is gonna undergo what? Reduction. Okay, reduction. And then so it's gonna be like this. Where's my is this table for P? Yes. Where's my Cl minus blah 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 blah? Okay, so I'm gonna write it like this. It's fine. I'm gonna say oxidation Cl minus forming me Cl2 plus an electron, and then for my reduction, I'm gonna say it is what is reduced is H2O. Okay, reduction is gain of electron, so it's gonna gain electron. Uh, how many electron does it gain? Two electron. Okay, let me write it as balanced as it is. Okay. Okay. I think now this is final. 2OH minus. Okay. 2OH minus. So this is that 2OH minus. So I can now be in a position of answering the questions. Define the term electrolysis. Remember electrolysis, it is the process of converting. It is the chemical process in which electrical energy is converted to chemical energy. Okay. Let me. It is the chemical process whereby electrical energy is converted to chemical energy. Which electrode is an anode? So we have already identified that an ox. Okay, anode. The anode is going to be my X electrode, and then write down the reaction that takes place in electrode X. Electrode X, we have already written that down. It's just a matter of making them clear. Sorry. And then electrode Y. Okay. Aha. And then they say to us a current of zero point 0.5 amps is applied over a period of 5 hours. Okay. Calculate the volume of chlorine at STP. So I collect my data and check what I'm given. Okay, they want me to calculate the volume of what? Of chlorine gas at STP. Okay, I know at STP I have molar volume to be 22.4 decimeter cube. Should be your stoichiometry. It means somehow I'm gonna need N, number of moles. Okay, number of moles of chlorine gas. Okay, I'm gonna need this information. Okay, because I remember stoichiometric equations use this again. But now, what am I given? I'm given current of zero point 0.5 amps, and I am given time to be 5 hours, which is equivalent to 5 times 6, sorry, times 60 rather. 5 times 6, it is 30, I think it is 3000 seconds. Okay. From 5 hours, I need to multiply by 64 minutes and then 64 uh, for seconds, which is multiplied by 3600. And then it gives me something like many hours thereof, I believe so. This should be many hours. Ooh, something like 18,000 if I'm not mistaken. 18,000 seconds, not hours. Mpo. 18,000 seconds. Let me see. 5 times 3.6. Yes. And then I know with this formula, I changing time, I can get what? Charge. Okay, I can get charge. Remember when you talk of charge, you talk of electrons. I get charge. Okay, if I have charge, if I can get charge here, and I know that charge N is equal to Q divided by E. Okay, I know that N is equal to Q divided by E, and I will already have calculated Q, and this is the number of electrons, by the way. And then, okay, and then I will need to convert this number of electrons, these ones, to number of moles. How do I do that? This N will be equivalent to number of moles. This is the number of moles that you see there, N divided by Na. This N refers to the number of particles, can be number of electrons, atoms, and all of that. So it means my first step will be here, and then second step, third step, and then the last step is here. So let's try to output that in beautiful method thereof. First thing first, I convert this information that I'm given to charge. Okay, so Q it is equal to I changing time. You know this from your formula. You have your formula sheet. Current it is 0.5 multiplied by 18,000. Okay, you needed to convert that to seconds. So this is 9,000 coulombs. Okay, I'm done finding my charge. Okay, I go to a number of electrons. Number of electrons it is equal to Q divided by E, and then Q is 9,000 divided by 1 electron, it is 1.6 times 10 to the power of negative 19. And then we get number of electrons to be something like 9,000 divided by 1.9,000 divided by 1.6 times 10 to the power of negative 19. It is 5.625. Okay, 5.625 times 10 to the power of 25 electron. Let me just confirm this with my calculator. 5.625 times 10 to the power of 22, rather, not 25. Electrons. Now that I have electrons, I need to convert this number of electrons to what? To number of moles using this formula of Avogadro's constant. Number of moles is equal to N divided by Na. Okay? Where this number of electron is here. Remember, this is number of particles, and particles include electrons, atoms, and all of those compounds and what. So number of electrons that we have, it is 5.625 times 10 to the power of 22 divided by Avogadro's constant. Okay, Avogadro's constant, it is 6.02 times 10 to the power of times 10 to the power of 23 there. And then I get number of moles to be something like uh, 0.09 0.093. But now this is a number of moles of electrons. Okay, so number of moles of electrons. Remember that we have this equation here. Remember we have Cl minus converting to Cl2 plus electrons. So we see that whatever mole of number of electrons, okay, this is not balanced by the way. So if it becomes balanced, it's gonna be like this. So I'm gonna, okay, this is the correct format basically, the balanced one. Okay, that needs to be balanced. Okay, what I wrote was not balanced here, and my apologies for that. This was not balanced. 2, and then this needs to be 2 electrons. Okay, I think the table can also confirm that with me. Where is it? Cl minus, here it is, supposed to be 2. Sorry about that. So when I have this, it shows me that for whatever, did I write it correctly? Oh, okay, okay, okay. So remember, I'm trying to find the number of moles, or rather the volume of Cl2. So it tells me for every 2 moles of my electrons, there is 1 mole of what? Of chlorine. So if I were to convert to number of moles of chlorine, number of moles of chlorine gas, it is half the number of moles of my electron, which is now in this case half multiplied by 0.093. And then it's something like 0.5, 0.093. Okay, I get something like 0.4 0.0465 moles. Okay, okay. And then what I can do now is say, okay, now that I have number of moles of chlorine gas thereof, this is mole. Now that I have number of moles of chlorine, I can now use this formula. Okay, I can now use this formula and say, okay, if I want to find the volume, remember it says N is equal to V divided by Vm. So number of moles, it is 0.0465. Okay, 0.0465. The volume is unknown, and then the molar volume, it is 22.4. And then the volume of the chlorine gas that I'm looking for, it is something like 1.04. Okay, 1.04 decimeter cubed. Let me recap these calculations. We were given the current, okay? We need to convert that current to the charge, okay? After converting to this charge, the off of mine, I need to convert this charge to number of electrons, okay? Number of electrons, okay? And then after getting the number of electrons thereof, using the formula, number of electrons is equal to charge divided by electron, I get the number of electrons that were transferred during the reaction. Which reaction? Since well, I'm focusing on this portion, during the reaction of that one, okay? And then I see that, okay, this much of electron were transferred, but I need to convert these electrons to what? To number of moles. I want to see the number of moles of these electrons that were lost thereof. Okay, so I convert this using now Avogadro's constant formula, and then it says number of electrons is equal to number of particles, which is that this is number of moles of electrons, this is number of electrons. Okay, number of moles of electrons, this is just number of electrons. Okay, let me do this. Okay, But remember, I'm still calculating for the electrons. So I get that my electrons have this much moles. But I be like, okay, I do not want the number of moles of my what? Of my electrons, but rather I want the number of moles of what? Of the chlorine. But I can use stoichiometric ratio to say, okay, the ratio between chlorine and electrons, it is 1 is to 2. Thereof, I use my ratio thereof. And then after getting the number of moles of chlorine, I can now be in a position of using my STP volume, and molar gas volume formula, the off. Then that's that. Okay, so yeah, yes, guys. Hopefully, it wasn't that bad. The calculations are gonna be following the same order. Hopefully, the next question that you're gonna do will have a similar structure, so that you see that most of the time you follow the steps as they follow. Okay, so thank you very much. Hopefully, you enjoyed.